Good morning friends. In mechanical properties of a fluid, we are going to discuss about what is the viscosity and laminar flow, and also we are going to derive the equation of coefficient of viscosity in terms of the stress and strain. Right? Okay. Now what is the fluid? Fluid, that means which can flow, that is known as the fluid. Either the any substance or the any liquid or the any gaseous state of a substance which can flow, that is known as a fluid. Now we have the daily experience in the body. Yet we stir the milk or the tea in cup with a spoon. So after the some time what's happened? Yet we stir the milk or the tea in a cup by a spoon. So as we remove the spoon, what's happened? The entire liquid or the milk or the tea perform or rotate in a cup of a tea or the milk. After the some time, what's happened? It becomes the stationary. So what is the reason why this milk or tea are going to steady position after the some interval of time? And when we stir this tea or the milk, we also show that the inner layer, that means in the center part, has the less velocity, has the more velocity compared to the milk or the tea in contact with the outer surface of a cup. Here we are going to discuss this thing. And also in summer season, whatever the water flowing in the river, we know that the upper layer has the more velocity compared to the whatever the layer of the water in contact with the bottom of a river. The layer in contact with the bottom of a river has the less velocity compared to the top. That means as we going from bottom to the top, the different layer of the water are moving with the different velocity. That means in a river, the water is not flowing like a bulge of a water. That is flowing in different layer. During this flow of water, different layers are moving with the different speed over each other. So this type of the flow is known as laminar flow. What is the reason why all the layers has no same velocity? At that time what's happened? What are the layer of water in contact with the bottom? Here the force between the molecule of water and molecule of bottom material has the force of attraction. Therefore, the bottom layer of water which is in contact with the bottom is almost stationary. Now the slight up layer of a water, there is the second up layer of a water, has the quite more velocity because here the force of attraction is exerted between the molecule of water of two consecutive layers. Thus, as we going up, so what's happened? The velocity of the different layer of the water are going to increase. Here we are going to discuss this thing in viscosity and also the laminar flow of a fluid. Now the question is that explain the viscosity and laminar flow of a fluid. So in laminar flow, any two consecutive layers of the fluid have the relative velocity between them. As a result, the resistive force is produced tangentially at the surface of layer in contact. And this internal force of friction is known as the viscous force. That is known as the viscous force. Now, as you consider here, the fluid is flowing like this manner. Yes, we are going up, so velocity increases. Velocity increases. That means, yes, you consider the bottom layer as the velocity is 0. Second has the quite more velocity. Here we consider the two consecutive layers. One has the velocity is v plus delta v, and second has the velocity is v. velocity is. Now here, the flow of the fluid is not taking place the entire bunch of the material flowing with the same velocity. But here, the different layer of the fluid or the material are slide over each other. And at that time, the two consecutive layers, this and this, has the relative velocity between them. Relative velocity between them. As a result, the resistive force exerted between these two layers, that is the resistive force. In the direction tangential, at the surface, tangentially at the surface of the layer in contact. So the resistive force is act between the two surfaces in contact in tangential direction. Right? This force or this resistive force is known as the viscous force. And the property of the fluid due to which the relative motion between the two layers is known as the viscosity of the fluid. Due to this property, here the fluid are flowing in form of a layer, different layer. This property is known as the viscosity of the fluid. Again, what is the viscous force and what is the viscosity? For linear flow, any two consecutive layers of the fluid have the relative velocity between them. As a result, the resistive force is produced tangentially at the surface of contact. And this internal force of the friction is known as the viscous force. The property due to which the relative motion between two layers is known as the viscosity of a fluid. So in short, due to the viscosity property, the fluid is flowing in form of a different layer with the different velocity. Clear this? And this property is known as the viscosity of a fluid. Okay. Now, how we can explain it? For that purpose, as shown in figure, suppose the liquid like a oil is enclosed between the two glass plates as shown in the figure. Here the figure is shown, there is the lower glass plate, there is the upper, there is the stationary. Upper plate is moving with a constant velocity. Constant velocity is V. There is the stationary, so its velocity V is equal to 0. Right. The bottom plate is fixed while the top plate is moved with the constant velocity V. Therefore, the relative to the bottom plate. The layer of the liquid in contact with the upper plate. Whatever the layer is in contact with the upper plate moves with the velocity V, and the layer of the liquid in contact with the bottom plate or the fixed surface have the zero velocity. Again, to explain the viscosity and also the laminar flow, how that is realized, we consider the fluid like a oil is enclosed between the two glass plates. Upper glass plate move with a constant velocity V, while the lower glass plate is fixed, that means the stationary. It is not moving. Right? Okay. Now, the layer of the liquid is in contact with the upper plate, also move with the same velocity of a glass plate. While the layer is in contact with the bottom glass plate, it remains stationary because the bottom glass plate is fixed. Do not move. The velocity of the different layer increases from top to the bottom to the top as we go up. So velocity also going to increases as we move from bottom to the top. So that is shown here. This layer has the less velocity compared to this layer. It has the less compared to this. And the maximum velocity has the top layer. That means the top layer has the maximum velocity, while the bottom layer has the minimum velocity almost zero. Thus, for any layer of the liquid, its upper layer pulls it forward, while the lower layer pulls it backward. This results in force between the layers. So in this step of the layer form, the top layer pull the liquid in forward direction, while the bottom layer pull the liquid in back direction. Pull the liquid in back direction. And this results in force between the layers. So as a result, the adhesive force in the direction of tangential arises between the two layers, and the relative motion between the two layers takes place. And this type of the flow is known as the laminar flow. Clear this? So here the concept of the laminar flow must be clear, because after this discussion we have also discussed about the Stokes law. Right? So at that time that is also on the base of the laminar flow. Again, what is the viscosity and what is the laminar flow of a fluid? Now, in laminar flow, any two consecutive layers of liquid have the relative velocity between them. As a result, the adhesive force is produced tangentially at the surface of the layer in contact. Here, the two layers has the relative velocity between them. So, as a result, the adhesive force is produced tangentially at the surface and contact between the two layers. Now, this internal force between the two layers, or this internal force of the friction, but this adhesive force is known as the viscous force. And the property due to which the relative motion between the two layers take place is known as the viscosity of a fluid. Right? Okay. So there is the viscous force and there is the viscosity. How we explain it? For that purpose, as shown in the figure, consider a oil fluid like a oil is enclosed between the two glass plates. That upper plate is moving with a constant velocity v, while the bottom plate is fixed. So as a result, the layer in contact with the upper plate also move with the same velocity of a upper glass plate, while the layer in contact with the bottom plate is stationary because the lower plate is fixed. Therefore, the velocity of the different layer increases from bottom to the top. That means, as you are going from bottom to the top, the velocity of the different layer increases. Thus, for any layer of liquid, its upper layer pulls it forward. So, for any layer, here we show the different layers. 1, there is the 2, there is 4. So, this upper layer pulls the lower layer in forward direction, while the lower layer pulls the upper layer in back direction, in backward direction. This results in force between the layers. That means, as a result, the adhesive force produced between the two consecutive layers. And this type of the flow is known as the laminar flow. This type of the flow is known as laminar flow. Clear this? Okay. Now we are going to derive the equation of the coefficient of viscosity in terms of the stress and strain. Stress and strain. Now, what is the strain? What is the strain? Or the longitudinal strain. Longitudinal strain, that means the change in length to the ratio of change in length to the original length, that is known as the longitudinal strain. Right? And what is the stress? Stress, that means the force per unit area, that is known as the stress. force per unit area, that is known as the stress, while the relative change in a quantity to the original quantity, ratio of relative change in quantity to the original quantity is known as the stress. Like as the delta L upon L, delta V upon V, delta A upon A. So these are the different types of the stress. And the stress is the force per unit area, that is known as the stress. Now we are interested to derive the equation of the coefficient of viscosity in terms of the stress and strain. Stress and strain. So here, for that purpose, consider a laminar flow of a liquid as shown in the figure. Already we consider the same figure to obtain the coefficient of viscosity in terms of the stress and strain. Consider a laminar flow of the liquid as shown in the figure. The upper plate moves with a velocity v, hence the layer in contact with it also moves with the same velocity. Here we consider this laminar flow of a fluid. The lower plate is fixed while the upper plate is moving with a velocity v. Therefore, the layer of the liquid in contact with the upper plate moves with the same velocity. Consider a portion of a fluid. We consider the portion A, B, C, D, and at some instant as the same is ABC. Here we consider this portion of the liquid at any instant of time t as the same is ABCD. Right? After the delta t time of interval, or the short time interval delta t, the shape of this fluid is take place AEFD. Initial, the shape of the fluid we consider is ABC and instant of time t. Now after short interval of time t plus delta t, that means after the delta t time of interval, the shape of fluid take the new shape AEFD. Doing this, the liquid has the undergoes a shear strain. Liquid undergoes the shear strain. There is our x. X is equal to v into delta t. How much distance is traveled by the p point of the fluid? There is the p. B is equal to s with velocity v in delta t time. Therefore, x is equal to v into delta t. Now, the width of a fluid portion is L, right? Therefore, the shear strain is delta x upon L. There is the delta x upon L. Already we discussed in properties of a solid when we define the strain strain. Strain strain is equal to delta x upon L. The strain in a flowing fluid increases with time. As the time increases, what's happening? So this shape is going this way. Therefore, the delta x increases and the same state it also increases. And the stress depends on the rate of strain. What are the stress produced in this portion of the fluid? That depends on the change in the strain. That depends on the rate of strain. Rate of strain is delta x upon L upon delta t. Therefore, delta x upon L into delta t. There is our strain, just mean delta x upon L. There is the strain upon delta t. There is the rate of strain. Whatever the stress is produced, this depends on the rate of strain. Here the same stress is the force per unit area F upon A, where the A is the area of contact surface and F is the viscous force. F is in the direction of tangent. Again, what's happened? There is not very easy, but keep in mind that our concept about the stress and strain must be clear. At that time we can understand this thing. That means the coefficient of viscosity in terms of the stress and strain. Now consider the flow of a fluid with the laminar flow of a fluid as shown in the figure. The upper plate moves with the constant velocity v while the lower plate is fixed. Therefore, the layer of the fluid in contact with the upper plate moves with velocity v. Now, at some instant of time, we consider the portion of the fluid A, B, C, D. This portion of the fluid take the new shape A, E, F, D in short interval of time delta t. Because the fluid is flowing with velocity due to the viscous force, it is also acting in tangential reaction between the contact surface of the two layers. Right? Therefore, consider the portion of a fluid A, B, C, D at some instant t. This portion take the shape A, E, F, D after the small or the short interval of time delta t. During this, the liquid undergoes a shearing strain. Shearing strain is equal to change in the shape to the width delta x upon L delta x upon L. The strain in a fluid increases with time. As the time increases, so this shape is also changes like this way. Therefore, the strain in flowing fluid increases with time, and the stress depends on the strain head. Here the strain is continuously changes with time. Therefore, how much stress is produced in this portion of a fluid, that is depends on the change in strain with time. That means the strain rate. Strain rate is the strain delta x upon L divided by time interval. Therefore, the strain rate is delta x upon L upon delta t, that means the delta x upon L into delta t. Now we know that delta x upon delta t is the velocity, therefore velocity upon width. Velocity upon width of a fluid. So there is also the strain rate. Now, the shearing stress is F upon A. We know that the stress is equal to force per unit area. Therefore, the shearing stress is F upon A, where the A is the area of the fluid in contact with the contact surface, and F is the viscous force in the direction of tangent. Now, for a fluid, the definition of the coefficient of viscosity N is equal to the ratio of the shearing stress to the shearing strain. Shearing stress to the shearing strain. Therefore, coefficient of viscosity N is equal to F upon E upon V upon N. That is the rate of shearing strain. F upon A upon V upon N. Therefore, Fn upon Va. Again, the coefficient of viscosity N is equal to shearing strain to the shearing strain. Shearing stress to the shearing strain. Shearing stress is F upon A. Now the strain rate is V upon L. Therefore, Fl upon Va. From this equation, the viscous force F is equal to Na V upon L. Na V upon L. N is the coefficient of viscosity. A is the area of contact, V is the velocity, and L is the width of a fluid or the length of a fluid. SI unit of viscosity is poisson, that is denoted by PL, and 1 poisson is equal to 1 Newton into second per meter square. Now the Newton per meter square, that is the Pascal unit of pressure. Therefore, 1 poisson is equal to Pascal into second. Pascal into second. And the dimensional formula of viscosity is M1 L1 T minus 1. Keep in mind this dimensional formula, that is important for the 1 marks question. the SI unit of the viscosity is Poisson, that is denoted by PL. And the relation or the 1 Poisson is equal to 1 Newton into second per meter square. Newton into second per meter square. Therefore, there is the Pascal into second, because the Newton per meter square is the Pascal into second. And the dimensional formula of viscosity is M1 L minus 1 T minus 1. Completed? Okay. So that is about the coefficient of viscosity in terms of the stress and strain. Only the coefficient of viscosity is saying stress to the same strain. Whatever the stress is produced, that is depends on the rate of the strain. Strain is the delta x upon L. The rate of the strain is delta x upon L upon delta t. That means there is the V upon t, because the delta x upon delta t is the velocity. Therefore, the same strain rate is V upon L. Coefficient of viscosity is equal to ratio of same stress to the same strain. That means the F upon A upon V upon L. Therefore, FL upon VA. So from this equation, the viscous force F is equal to NA into bracket V upon L. SI unit of viscosity is Poisson. And 1 Poisson is equal to 1 Newton into second per meter square, or that is also the Pascal into second. Keep in mind this SI unit. And its dimensional formula of viscosity is M1 L minus 1 T minus 1. Clear it? Okay.